This was the planning document that really brought Haarp into being, and the absolute requirement of 1 gigawatt, which is a billion watts, all the way up to 10 billion watts of effective radiation power with a desired level of 100 billion watts.
At its biggest size suggested, if you beamed it for an hour and a half, that would equal the energy in a hydrogen bomb.
Imagine the Earth's atmosphere, also known as the ionosphere, as a thick soap bubble. It is a membrane, a natural electrically charged shield around the Earth, protecting all life from deadly solar radiation.
I don't think we should do anything to damage it.
Without the ionosphere, I'd be fried, you'd be fried, all life on Earth would be fried.
In 1912, Nikola Tesla, a visionary genius, saw ways to tame the sky, to make the atmosphere glow. He developed alternating current, high-frequency radio technology, and free energy. He experimented with both high and low frequencies and electromagnetic waves. He envisioned altering the weather and creating shields around the Earth to protect us from missiles, and he claimed he knew how to split the Earth in two. In 1985, Bernard Eastman applied for patents that could make some of these ideas real. Many claim that these patents have become the blueprint for Haarp, High-Frequency Active Auroral Research Program.
Haarp is a large antenna where we beam radio frequency energy up into the upper atmosphere.
Applications discussed in the patents included destroying missiles. Communications, control, and disruption were included. There were some other ideas, both to possibly modify weather and finally to lift a portion of the upper atmosphere further out into space where hopefully it would be able to deflect missile trajectories.
The ionosphere of the Earth has got enormous amount of energy. There are 8,000 thunderstorms going on all over the Earth at any given moment. There are millions of amperes of electricity pouring to the Earth from lightning strikes. And Haarp could create a trigger effect.
Haarp uses 1 billion watts beamed straight into the ionosphere for experiments.
While we feel that Haarp is a unique facility, it's not the only one like it in the world. Haarp has some capabilities that we feel are better than some of the others. You can change the frequencies. You can shift the beam so that you can move it from one part of the ionosphere to another, and it has quite a bit more power than some of the other facilities throughout the world that are doing the same kinds of research. Haarp can create some of the effects that the sun creates that are similar to the aurora borealis.
Haarp focuses 3.6 million watts and squeezes it into a billion-watt or gigawatt beam.
We're squeezing the megawatts into a narrow beam, then in a very tiny area, you can create what's called an effective gigawatt.
The Earth is a web of interconnections. How do we know what we're doing when we blast the upper atmosphere with a huge amount of energy?
In certain applications, the military acknowledges that it can literally lift the ionosphere, and what they say is it's not a problem, yet when you lift the ionosphere up, the lower atmosphere rushes in and fills that void, which changes localized weather patterns.
As they acknowledge in their papers when they say, we don't know what will happen when we push it to the next level of effects.
The military record explains it as phase one of a multi-phase project. It's going to get bigger, it's going to continue, and that's again why we're concerned.
There's always a limit to everything. Although we don't know exactly where that limit is.